Hello everyone, this is Eric, your Revit tutor. If you want to learn more about Revit, subscribe to my channel and follow me on Facebook. Or if you have questions about Revit, flick an email to yourrevittutor@gmail.com. In this video, I'm going to show how to add a parameter that automatically calculates the cross-sectional area of a hollow steel, and this time we are going to study the circular hollow steel CHS or HSS round. So from this default project here, let's select the circular hollow steel, which is not available here in the default project. So we will need to load a family and go to, let's say, US metric and structural framing, steel, and let's select the HSS round and select any size here. Okay, and that's it. Here's our pipe or our hollow steel section, round hollow steel section. Okay, now we double click this and that will bring us to the family editor of this family, and let's go to the properties here, and as you can see, the section area is not driven by formula, and that is our goal here. We will create a parameter for area that automatically calculates the cross-sectional area, and to do that, let us assign D for the diameter. So let's create a parameter for diameter, which is D. Okay, that's length, and under dimensions, just click OK. And let's see, let's copy diameter here and paste it in the formula. And the next thing that we need to do is to create a parameter for thickness, for the nominal wall thickness. So let's create thickness T, then click OK, and then just copy this one and paste it here. Oops, sorry, it should be here, T. Then let's bring this up. Okay, and what else do we need? So I think that's all, because these are already driven by formula, the centroid horizontal and centroid vertical. So that's all we need for circular. Let's click apply and OK first, and then type UN to change the unit, and let's set the unit for area to square millimeters with 0 decimal places. Click OK, OK, and then let's go back to the type properties. Now let's create the area parameter. Let's just say it's A. Okay, A, and go to area under the type of parameter. And as you can see, it automatically changes the group parameter under to analysis results. Let's just go back to dimensions, because we don't want our result to be somewhere else in the parameter list. So let's go to dimensions and then click OK, and then let's move this downward here. And what's the formula for the cross-sectional area of the hollow circular steel? Let's see here Okay, it is actually just the area of the big circle minus the area of the small circle. So let's just copy this one. Let's copy the formula and paste it here, but it will result to an error because I added here the pipe, which is not available here. For some reason in Excel you cannot use the same name for the formula, so I needed to rename this. But here in Revit, since there's no other family that is open or it is not in a project, yeah, there's no conflict, so just use D and T. All right, so the result is 11,870. Let's check that if it's the same when we input this 250 and 10 thickness. Let's see, 250 and 10 thickness, 7539. Is it 7539? Yeah, because it's 7540. It rounded to the nearest tens. So okay, so our answer is correct, 7539.84. But this time I'm going to show you how to add another parameter, which is the moment of inertia. As long as you know the formula, it is easy. But let's link this one first. Let's link the section area to the area here that we have calculated or we have created. Okay, 7539.84. Okay, so once we apply this and click OK and then save it, this family will be automatically calculating the section area for this particular section. All right, now let's create another one, which is moment of inertia. And moment of inertia should be what? It's millimeter to the fourth. So we need to select here inertia, but there's no inertia here, so we need to go to change the discipline to structural and go to moment of inertia right here. Where is it? Let's just search for moment of inertia. There, moment of inertia. And let's say it will also appear under dimensions, just for the ease of looking at it. So let's just assign it as I, then click OK, and I stands for inertia. And as you can see, the default unit is already in millimeter to the fourth, so we will have no problem with that. Now let's look at the formula for inertia, moment of inertia. Okay, here it is. That's pi times d squared to the fourth minus the inner diameter squared to the fourth. Okay, so that's our formula. All right, let's divided by 64. Okay, let's delete the word pipe here. We don't need that. We only need D and T. And then, okay. So the result is 500, oh, I mean, 1, 2, 3, whatever. I think that's 54 million or 5 million. No, 54 million. Yeah, 54 million. Which is same here. Yeah, 54,381,096. So that's our moment of inertia. And we can now link this to here and here because it's round. So the moment of inertia along the strong and weak axis are the same. So that's it. So that's how we add moment of inertia, and we can do it with other sections, other shapes like the I section, the hollow steel, rectangular section, and square sections. Just input the formula on the right formula for moment of inertia, but be careful about the moment of inertia with regards to the I section, because the moment of inertia along strong axis is the same. It's not the same with the moment of inertia along the weak axis. So there's a different formula for the strong and the weak axis. So I hope you have learned something from here, and I hope to see you soon in my next video. Thank you very much.